focus. Holy moly's. It's getting hotter. How you doing, guys? Just a little quick update. Like I said, I'm not going to be working on this motor for a couple of days. Just came back from school. Go back again tomorrow. So time is very limited. Doing the show on Saturday, so we'll be back on this thing on Sunday for sure. But I want to switch alternators. My car here, okay, that's a Mitsubishi alternator in the car. This 64 originally had a generator. Okay, old school, big can type generator. Worked mint, I guess, for the 5 amps I'm sure I put out. But I wasn't going to transfer that over to the engine. Next choice would have been to go with just a regular GM 73 Delco alternator. 73 and newer. Has the internal regulator, so it's a 3-wire alternator. Okay. I don't think a 1-wire alternator is required. But they're good. They're reliable. I actually have one. I think I have a chrome-plated one from Udizzy that I won in the contest. Okay. I have 4 of them from Cash from Clunkers. I have the original one from the Concord, which I think is a 35 amp. I think I have a couple that are much higher than that. They're good. They're reliable. Do I need a lot of power in the Concord? A lot of amperage? No. Why do I like these type of alternators like I have in the wagon here? One, they spin faster and continue to work. Okay, constantly this thing's at 6,700 RPM. And I have the ratio set up that it actually spins, okay, to the same speed it would have spun when that was on the Mitsu. That alternator was brand new when I put it on. Okay, it was also a serpentine belt alternator. It's an 80 or 85 amp alternator. So I like them because they put out more amps at an idle. Okay, and on my car, and if anybody's ever into bracket racing, they know what I mean when I say this. Mine, I could turn the alternator off with the ignition key and still have the car running because I have the magneto. But old school tricks was on top of the alternator, you mounted a switch. And if you turned off the current to the alternator, you didn't have to drag, you would just spin in a pulley. And people could actually gain a couple of tenths at the track by turning the alternator off. On the other hand, you are now running your electronics at 12 volts and lower. On my car, there is no electronics. It makes its own current. So when I start up the car, this alternator turns on, replenishes the battery, and that's the extent of it. Unless I turn the headlights on. So, Junior's car, on the other hand, okay, it doesn't really have many more accessories on it, but I have the same feelings. This engine originally had a GM alternator on it. Okay, could have sworn the bracket was modified to fit it because only certain years had it. Okay, the 6-cylinder that's in this car now is definitely GM. Super easy to wire. It's 3 wires. You got the heavy wire coming out. You could do that multiple ways. You could run it straight to the battery, or depending on if you have a solenoid or not. Say you have a Chevy, you run that wire usually to the solenoid, and then they run a wire from there into the car and do all its things. This car has an actual solenoid here and the solenoid on the starter, and the reason I still run 2 of them is that makes the wire going down to the starter dead. Okay, and you want the wire going down to the starter dead. So the only thing live is from here to here, and it just loops down, it just goes there. That means this wire is dead. So that means when I'm cruising around, that wire lands on the header, I don't have a car fire. Okay, now I could pigtail off of here like some of the factory wiring is, and that goes into the car. Or if you need something in the start circuit, you grab it on this side and you say to yourself, well, what do you need in the start circuit? Well, on an older car, the coil, which I actually have one, and that's the way it was in my toolbox, Delco Remy. Okay, the coil has the negative side, right? Negative side goes to your distributor. The points actually open and close the negative side. Okay, positive side, most times there's two wires to it. One goes to your key and either goes through a ballast resistor to drop it close to 6 volts, or it goes through a resistor wire. It looks just like a regular wire, but the wire has X amount of resistance per inch, and they use X amount of wire, and that drops it down to 6 volts. That's why if you're working on an older Chevy, you never saw the ballast resistor was in the wire. Then when you turned around and put your big yellow coil on, or your MST, you was only running 6 volts to it. But that's a different situation. Why do they run 6 volts to it, and then why do they run the second wire? The second wire goes down to the starter solenoid. So when you're cranking the car, it runs 12 volts to the coil to make a hotter spark so it could start. Then when you turn the key back to run, it goes back to the 6 volts. And the reason they do that is A, they want a hotter spark to get your car running. B, they got to kill the voltage back or you're going to fry the points. So if you eliminate the resistor wire and the ballast resistor, either one, first of all, you got to make sure your coil's meant to run 12 volts through it. And two, this could either explode. I've seen that happen. These things go off, they go off like M80s. And everything leaves everywhere. You don't want to be around when it happens. And like I said, you can fry the points. Now, Junior, we got Denso alternator right here. Okay, has a little age to it, but I know for a fact that this alternator has less than 50,000 miles on it, and there's mint. There's nothing wrong with it. Okay, already loosened the pulley. Now these are a little different than like your old school GM alternators and the other ones. This does not require a taper or a keyway. It's just a straight shaft, and it actually gets pressed between here and the nut when you tighten it. Fits on there with a nice machine nice machine interference angle, and that's it. And in reality, it spins this way, so every time you accelerate, it wants to tighten the nut anyway. It doesn't want to loosen it. Now, if you go a little newer than this, they run a one-way clutch on here, a mechanical diode. So when you accelerate, it accelerates. When you decelerate fast, the alternator actually freewheels on the pulley, and those are the ones that have the cover on them. When you start seeing the rust come out of the cover, you'll know it soon what your problem is. So this will be converted over to a single groove pulley. Obviously, we're going to open it up, we're going to clean it, we're going to paint it. But we're going to put this one on Junior's engine right here. Now, I actually have it upside down for the mounting. Where you see this bolt coming through, we're going to come off the back bolt here on the cylinder head. This is actually coming off the engine. This we don't need for what we're doing. That was for the AC setup or whatever it is. That stud's going to be extracted. You run this bolt hole right here, just like I did here. And this one has a spacer I made up here, a spacer I made up there, and this is the factory setup on this particular year that I use this from. Okay, and then here's the factory triangulated bracket. This is also highly modified and upside down. This is the bottom of the alternator, which would be there. But we're going to leave this the way it is, and the way this alternator mounts on a car is it fits in a piece of aluminum, which would be on the front cover, right? And when you put this bolt in and tighten it, it actually slides this collar over right here and clamps it in there. So basically what's going to happen at this point is you just put the bolt back in, put it in a couple of threads, you support it here, and you tap this piece out. Now the new bushing is going to touch here, go through that hole with a nice fit, and to be whatever length it has to be. Oops, sorry guys. To put it where it's required. Here. Then the bottom bolt, which you still see sticking out, will be on the swing bracket. Now the difference between this alternator, and if you look, looks like there's a factory harness on there. And this alternator is, that's a 3-wire like a GM. There's a 4-wire. So, and we'll take care of that. We got the schematic right here. Piece of cake. It's actually pretty easy. You look at it quick, you don't think it is. This one right here is this post right here. They run it around, they run it through a 100 amp fuse. So that's telling me that an alternator is under 100 amps. I can look up what it is. It's probably going to be 85, maybe 90, even 95. Believe it or not, they run it that close. So that's a piece of cake. Then you go one wire over, which is the S terminal. S terminal just comes around hot all the time. That they run a 5 amp fuse. In case the circuitry burns out, it pops the fuse. Okay, so both of those are hot all the time. Okay. This one right here, the ignition circuit, runs up. They run it through a 10 amp fuse. It is hooked to ignition. Okay, we got 3 of the wires taken care of. 4th wire, the L circuit, comes up. Excuse that for a second. We come around. Here's your ignition switch. Okay, they run a 15 amp fuse. You have ignition 2 and you have start 2. So basically, when you start the car, it goes down to this lug. Does not feed anything on the alternator. So as the car's cranking, the alternator is dead. This is what you would consider an exciter wire on an old GM alternator or any other alternator. Okay? But as soon as I let go of the key and the car's running, it powers it up. Now, forget about this again. This wire here, on some models, goes to the ECU. And the reason that goes to the ECU is when you fire up your car. Okay, so say it's cold out. You crank up your car. And the car cranks for 5 seconds and fires up. Okay, you just took a massive amount of juice, current, built up energy, stored energy out of the battery. The alternator is stupid, doesn't know any better. Okay, the alternator is using this wire right here to sense how much voltage is in the circuit. That's why this wire could be actually looped to right here. Okay, so it's sensing how much current is in the system, which you could actually read off this wire. So it's going to tell you, okay, the battery just went from 12.6 volts, now the batteries are in 12 volts. I need to put current out. I need to bring it up to the regulated amount, which is around 13.8, 13.9 volts. And it's going to take X amount of amps to do it, and that's what regulates it. Through the diode triode, and you got your one-way diodes here, and whatever. So, getting back to this. So what the computer does on some model cars, and it's been doing this for quite a while, is you fire up the car, it delays a couple of seconds, then turns the alternator on. Okay? You could tell if you don't have that, because if you fire up your car and the belt instantly squeals, that means the alternator is instantly on. But there's a lot of models out there that'll fire up the car, let the car run for a couple of seconds, stabilize, and then turn the alternator on. They do it through this wire. Now here, we have the charging light in the combination meter. Okay? And if you follow it down, it goes through a resistor. There's a resistor parallel to it, so you got 2 resistors parallel. So that means whatever this resistance is cut in half. Okay, so if it was a 10 ohm and 10 ohm, it would be 5 ohms resistance. You got 2 paths. You got a light emitting diode. Okay, there's your diode. There's your little light emitting signal there. I don't know if I'm getting it in there. And below it you have a diode. Okay, which they put in there because this is a diode. Now, in the olden days, okay, now I'm not going to go too old now, but in the olden days, this was just a regular 194 light bulb. A 194 light bulb with a resistor paralleling it. Okay, and between the 2 of them, that was enough resistance to send enough current to the alternator to excite it. Now here's how it works. You turn the key on, it sends the hot down. The car isn't running. This is grounded. So here's the ground. Okay, this is the ground. Here's the hot. They come together, the light bulb goes on. So you turn your key on in the dash, the light bulb's on. You fire up the car, this stays hot. This goes from a ground to a hot. So sends a positive 12 volt up there. Positive and positive turns the light bulb out. Okay? If the alternator stops charging, this becomes a ground again, and your alternator light will come on. When you see the alternator light dimly on or flickering, usually there's a problem with a diode starting to leak. And it'll actually allow negative current to trickle up. You don't get the full amount, Okay, so for argument's sake, source voltage might be close to 14 volts on this side, but here coming back up, you get a resisted value. So if you were testing it, it might only be 2 volts. So when you put system voltage positive on one side and a resisted voltage on the other, you get a dim light bulb. You have a resistor, just like, you know, a resistor or a rheostat, radio volume, light on the ceiling, whatever it is, because you're getting resistance through some of these diodes, which should be a one-way door, but they're not, they're leaking. Okay, so this actual system right here is coming out and will be replaced with a bulb and a resistor. Now, in the olden days, they ran just a bulb. And when the bulb took a crap, the alternator stopped charging. And if you were unaware of that, you would start digging into the alternator. Well, first of all, you should check to see if you have voltage here. But that usually got past people, so they would start putting alternators in the car. Then when they didn't have voltage there, they had to figure out why. The key is, when your alternator does not work, first thing you do is turn the key on and make sure the light bulb lights up. Especially on a classic car. Okay, when you get deep into the 60s and the 50s, you make sure that light bulb works. Now, they parallel a resistor there, so when the light bulb burns out, the current goes through the resistor, comes down, and still excites this. So at half the resistance, or the full resistance, whoops, I'm pointing the wrong thing, it's not too much current or too little current to excite it. So all you're doing is you're looking to excite it. Okay? So with that said, this is what will be going into the Concorde. Okay? The hardest part is just going to be making the brackets. When I did the one that's on the wagon, I actually did that while I was in the car. I had that on my Ambassador, and I transferred that over to this car. So this is going to be cake to do. The hardest part is going to be just get a bushing that's this diameter. Once I do that, we're golden. We just have to take a measurement. There's a place that I deal with here on the island. All they do is alternators and starters. If you guys remember videos back, 2 years ago, I did the Mitsubishi alternator. I bought the solenoid, and I bought the complete brush pack, complete with the plate, the 4 brushes, everything from the guy. A place called Anflow. All they deal with is alternators and starters. So that's where we'll be heading to swap this out. I'm going to see what size pulleys are available, and to me the bigger the better, but whatever we land with, we're going to have to settle for, because you got to understand something. The original pulley that's going to turn this is smaller than the one I'm going to be using on my crankshaft. So my crankshaft's going to spin this thing faster. But on the other hand, Junior's never going to take this car above $6 grand. The car this came off of, the red line was 7,500. Okay, so either way, we're not going to over rev it, and there's a good chance if we get a V-belt, it's going to be bigger than this anyway. But I will be taking the calculations to see where I land. The pulley that's on the other one always seemed to work well. The other pulley is actually 2 pieces, and I had to do machine work to tighten up the V on it. But so that's pretty much it. I wanted to show you guys that. It's not a major project, you know what I mean? But I think in the long run, we'll be much better off. I'll never think of the alternator again. Like I said, we'll clean it up, maybe split it, maybe just paint the case, put it back on, call it good, make it look a little nice. Like I said, this is a driver. And that's going to be it. And this I brought home because this motor's getting fired up with points, and this is actually an original points coil. So I know this is a 6-volt coil, and I know this coil actually came from the distributor I'm about to use. So I stripped this thing down years ago. I don't remember why, what the deal was with it. I just know it has 2 dents on it. So this is what the MSD coil should look like when we get it. So I want to dig out the original bracketry, and that puts the coil somewhere over here. I think it's standing up over here, some stupid shit or something. So with that said, guys, when we do get back out here, which will be this weekend, we are trying to button up the front of this engine. We're trying to get that pan sanded and painted.